Assalamu alaikum everyone. क्या हाल है? Okay, so the correct answer to the previous question was बता रहा हूँ. So we'll solve it as it is. 3x plus 2 equals to x plus 4, and then 3x plus 2, which is equal to minus x plus 4. Okay, one with the plus sign and one with the minus sign. Okay, then you will have x equals to 2x equals to 2, which means x equals to 1. That's one solution. And then in this case, you will have 3x plus 2, which is equal to minus x minus 4, which makes it 4x equals to, let me see, 4x equals to minus 6 and x equals to minus 3 upon 2. Okay, now the thing is, both these answers are correct. You just need to make sure that uh, it satisfy the modulus equation. So plug it back in. So plug in 1. So 3 into 1 plus 2. Okay, take the absolute of it and see if it's equal to 1 plus 4. It most likely will be. Okay, so with modulus, make sure that you check your answer. So 5 equals to 5. That's correct. Okay. Then check with x equals to minus 1.5. See if it holds true as well. So 3 into minus 1.5 plus 2. See if that's equal to minus 1.5 plus 4. I think this also holds. Okay, minus 3 upon 2 does not satisfy. Are you sure? Okay, let's see. 3 into minus 1.5 plus 2. So this is equal to minus 2.5. Okay, and 4 minus 1.5 is also equal to 2.5. So both of the answers are correct. Okay, minus 1.5 and 3 upon 2, they're both correct. Okay, so whoever said minus 3 upon 2 and 1, good job. Okay, now, so as you can see, we're doing vectors today. Now, I'm not going to be going over the concepts of vectors. We don't have time for that, because if you want to go over the concepts, then I have a separate video on it. I uploaded it recently. You can watch that. So why won't we apply the magnitude formula for 3x plus 2? Okay, so you can do it by squaring both sides as well. Yeah, that also work. You can square both sides and then solve. That will also work. So how will we know when to use radian mode and degree mode? Just read the question. If it's a circular measure question, then it's going to be done in degree mode. If let's say it's a differentiation question, but you have trigonometric functions and x is in terms of pi, then also it's done in radian mode. Okay, anything else will be done in degree mode. So, okay, I'll make a video on when I make the good luck videos. I'll mention how you should attempt the past paper as well. Okay. Please do the May June. Okay, okay, I'll do that. All right, now let's start. Okay, so for those of you who are asking for concepts of velocity vectors and concepts of vectors, I'm afraid we don't have enough time. Okay, and don't worry about it. I have a separate video on it which you guys can watch. I uploaded it recently only. Okay, learn the concepts from there. That's the only reason why I'm not doing concepts today, is because I already have a video on it. Okay, so, and if let's say your concept for math vectors are strong, not like super strong, but if let's say you have good concepts for math vector questions, then you won't have trouble in these questions. Okay. All right, now let's start. Just give me a minute. Let's start. Okay, now, like I said, that we will be solving past paper questions. Now, I'll try and solve past paper questions in a very elaborative manner so that you're able to understand the concepts through the questions. Okay, that's the max that I can do for you guys. क्योंकि अगर हम कॉन्सेप्ट्स करने बैठ गए ना फिर तो हमारे पास टाइम ही नहीं बचेगा क्वेश्चंस करने का. Okay, so let's take a question and let's solve that question. Okay, now the questions that I will solve will be in such a way so that we're able to cover all the main concepts. Okay, so let's start with this question right here. Okay, this is a fairly easy question. It's old as well. It's from May June 2011, paper 12. Okay, so here's what it says. It says relative to an origin. And by the way, okay, the good news is I've uploaded the notes. Okay, check the description. You will find my notes of vectors in the description. They're pretty elaborate and they will definitely help you guys, inshallah. Okay, now let's get to work. So here's a question, like I said, from May June 2011, paper 12. So it says relative to an origin, A and B have position vectors so and so. So that means the first vector that you're looking at is actually OA, which is 5 and minus 6. Okay, and OB is 29 and minus 13. Okay, now you need to find a unit vector parallel to AB. Now what exactly is a unit vector? Let's write that down. Unit vector is a vector divided by its magnitude. Okay, unit vector is basically the vector divided by its magnitude. Okay, now what we have to do over here is we need to find a unit vector, but not only that, we need to find a unit vector which is parallel to AB. Okay, so first things first, how do we find AB? AB can be found by simply doing OB minus OA. Okay, OB minus OA gives us what? Gives us AB. Okay, so let's do OB minus OA. That means 29 minus 13, and from it let's subtract OA. Let's see what we get. So 29 minus 5, let's see what that is equal to. 29 minus 5, so that's equal to 24. Okay, and minus 13 minus 6. So what's that equal to? That's equal to minus 7. Okay, and one thing, as always, I forgot to mention it. Those of you who are watching, please like the stream. It would mean a lot, as always. Okay. Now, so here's vector AB. Now, if you want to find out the unit vector of AB, better read the title. Read the title, you'll find out whether it's maths or ad maths. I mean, is it really that difficult to read the title? Now, here's a vector AB. Now let's find out the magnitude of vector AB. Okay, and how do you find out the magnitude of any vector? You do the square of its x component plus the square of its y component. So 24 squared plus minus 7 squared, square root of 24 squared plus 7 squared. So that's equal to 25. Okay, so here is the magnitude of vector AB. Okay, now next you're supposed to write down the unit vector which is parallel to AB. So here's what we're going to do. You have multiple ways of writing the final answer. You can either write it like this: 1 upon 25 into 24 and minus 7, or you can take the 1 upon 25 and multiply it by both the components. That means you can multiply it by 24 upon 25 or as well as the y component, in which case it becomes minus 7 upon 25. Okay, so there you go. That's your answer. Okay. Next part says the points A, B and C lie on a straight line such that 2 times of AC is equals to 3 times of AB. Find the position vector of the point C. Now finding out the position vector of point C basically means that you need to find out OC. Okay, now you need to do some manipulation, some plus minus, and somehow bring OC over here. Okay, so how can I split open AC? That's what the question is. How can I split open AC? AC you can split open by simply doing OC minus OA. Okay, OC minus OA will give you AC, and this is equal to what? This is equal to 3 times of AB. Now the good thing is, since we already know what AB is equal to, there's no need to rewrite AB as OB minus OA. We're just going to use the answer from the previous part, which is 24 and minus 7. Okay, So this becomes 2 times of OC minus 2 times of OA, which is equal to 3 times of AB, which means 3 times of 24 and minus 7. All right. Now we have to somehow make OC the subject. So that's what we're going to do. 2 times of OC minus 2 times of OA. Now what's OA? OA means basically the position vector of A, which is 5 and minus 6. So let's write that 5 and minus 6 equals to, now let's start simplifying this. 3 into 24, that's 72. Okay, and 3 into minus 7, that's minus 21. All right, now let's see what happens. Here's what we have. 2 times of OC is equals to 72 minus 21 plus 2 times of 5 and minus 6. Okay, so 2 times of 5 and minus 6 basically becomes 10 and minus 12. And don't forget the 72 and 21. All right, now remember, this will not give you OC, this will give you 2 times of OC. Okay, so let's figure this out. 72 plus 10, so that's 82. So 2 times of OC is equals to 82. And minus 21 plus 12, minus 21 minus 12 actually. Minus 21 minus 12 gives us minus 33. Now how will I make OC the subject? OC will be now equal to 82 upon 2 and minus 33 upon 2. So what's 82 upon 2? 82 upon 2 is 41. And what's minus 33 upon 2? That's equal to minus 16.5. So there you go. This is the position vector of C, or in other words, the coordinates of C. Now, even if the question had said find the coordinates of C, we would have done the exact same thing. Wa alaikum salam. Yes, finding the coordinates of the point is the same as finding the position vector. OC minus OA. Okay. So AC, remember subtraction of vectors. Remember how subtraction of vector works. If let's say you're doing OB minus OA, so can these two vectors be subtracted? Yes, they can be subtracted. Okay, and you can subtract this and write AB. Okay, just like that. If let's say you do OY minus OX, can you subtract these two vectors? Yes, you can. Why? Because they both have the same starting point and the end result is going to be xy. So remember this hack basically, that the element that's near to the equals to sign comes near after the equals to sign as well, and the element that's further away from the equals to sign is the element that comes after. Okay, so near comes near, further away comes further away. Just remember that. And here also you can see the letter that's near the equals to sign comes first, the letter that is away from the equals to sign comes after. I am using PDF Expert. Okay, khair. Anyway, so I hope that's clear. Now let's move on and do some other type of questions. Now these type of questions are very common. You can expect them when there's a vector question. You can expect a question like this as well. Okay, how to convert vector to coordinate and vice versa. So if let's say you have a coordinate, you have the coordinates of a point A, and A is let's say 3, 5, then you can write that as a position vector. All you have to do is write OA and then 3, 5. Okay, so if you write the points, if you write the coordinates of a point in column vector form, it becomes a position vector. Okay. Okay, now let's do this question. Let's see what this question says. So this question says in the diagram, OA equals to A, OB equals to B, and AP is equals to 2/5 of AB. Okay. Then it says given that OX is equals to mu times of OP, okay, where mu is a constant, express OX in terms of mu A and P. Okay. All right, let's see what we can do over here. Okay, now OX, notice what OX is equals to. OX is equals to mu times of OP. Okay. All right, and what else do we know? Here's what we know. We know that AP is equal to what? AP is equals to 3/5 of OP. Okay. AP is equals 2/5 of AP. All right, that's what we know. AP is equals to 2/5 of AP. So that means AP So first of all, let's work out AB. Okay, before we do anything else, let's work out AB. Okay, now how can I work out AB? Here's what I can do: AO plus OB. So doing AO plus OB will give me what? Will give me AB. Okay, so let's do that. AB is equals to what? AB is equals to minus A plus B. Okay, why minus A? Because we're coming in the opposite direction. Minus A plus B. Okay. Now, what are we going to do next? Chalo, question for you guys. Tell me one way which I can use and find out OX. Tell me how exactly can I find out vector OX? By finding OP. That's correct. That is correct, by finding OP. Okay, so let's see if we can do that. All right, let's see if we can find out OP. So do we have enough information to find out OP? Yes, we do. Okay, so OP can basically be found by simply going from OA to AP. Okay, now as far as OA is concerned, we already have that. Okay, as far as OA is concerned, we know that O to A is A. Okay, but what about AP? Now notice AP is equals to what? AP is equals to 2/5 of AB. Okay, and now that we've already worked out AB, all I have to do is replace AB with minus A plus B. Okay, so let's do that. A minus 2 upon 5A plus 2 upon 5B. So what's A minus 2 upon 5A? That's going to be 3 upon 5A. Just use your calculator for this. Plus 2 upon 5B. So what's this equal to? This is equal to OP. Okay. Now if you go back to the question, notice what the question said. The question said that OX is equals to mu times of OP. So OX was dependent on what? OX was dependent on OP. Now that we have OP, all we got to do is multiply it by mu and find OX. So OX is equals to mu times of 3/5 of A plus 2/5 of B. And there you go, fellas. That's your answer. By read the title, you'll find the answer to your question. I think you guys are the same people who don't read the instructions in the exam. Okay, so just read the title, you'll find the answer to your question, whether this is math or art maths. Okay, and for those of you who are worrying about maths, well, don't worry about it. I'll do a stream of maths tomorrow, inshallah. Yes, IGCSE and O-level, they're both the same. Okay, that's a logical question. Yes, IGCSE and O-level, they're both exactly the same. Okay, the papers are the same, the exam dates are the same, everything is the same. Okay, now part 2. Part 2 says, given also that AX is equals to lambda times OP, where lambda is a constant, use a vector method to find the value of mu and lambda. Okay, so basically here's what we have to do. Whenever you have a question like this, where you have two unknowns, you have lambda, mu, and you will come across lots and lots of questions like these. So the way to solve questions like these is that you find the same two vectors, one in terms of lambda and the other in terms of mu. Okay, whatever constant there is. So I repeat, whenever the question introduces two unknowns and then it asks you to form two vectors, and then there's a follow-up question where you have to find out the value of those two unknowns, the two constants. Then what you do is you find out the same two vectors, one in terms of lambda and the other in terms of mu, or like I said, whatever constant the question is using. And because they're the same two vectors, that means they both must be equal. And because they're both equal, that means we equate their coefficients. We equate the coefficient of A with A and coefficient of B with B, and then we solve. Okay. So if you've understood what I just said, that's brilliant. If you haven't, nothing to worry about. I'm gonna be solving it anyway. So notice that here I have OX, which is mu into 3/5 of A plus 2/5 of B. Okay, and now all of a sudden the question has introduced lambda, which I have to find. So what I'm going to do is I'm going to find out OX again, but I'm going to do it in terms of lambda this time. Okay, so I repeat, I'm going to find out OX again, but this time I'm going to do it in terms of lambda. Okay, now how can I find out OX? I can find out OX again by simply doing OA plus AX. Okay, so OX I can find out again by simply doing OA plus AX. Alright, now what's OA equal to? OA is equals to A. Okay, what's AX equals to? AX, as the question told us, is equals to lambda times of OB. And what's OB equal to? OB is equals to P. Okay, so that's great. That means OX can now be written as A plus lambda times of P. Now notice this is also OX and this is also OX. Okay, what can I do now? I can now use this information to find out the value of mu as well as the value of lambda. So here's what I'm going to do. Let's write OX over here. Okay, so OX is equals to 3 upon 5 mu plus 2 upon 5, 3 upon 5 mu A actually. 3 upon 5 mu A plus 2 upon 5 mu P. Alright. Now, what is the coefficient of A on the left hand side, or you can say what is the coefficient of A from this, in this OX it's 1, and what's the coefficient of A over here from the in this OX? It's 3 upon 5 mu. So what does that mean? That means 3 upon 5 mu equals to 1, and now if you cross multiply you can find out the value of mu, which is equal to 5 upon 3. Now this gives us the value of mu. We still have to find out the value of lambda. What's the coefficient of lambda from this OX? Or what's the coefficient of B from this OX? It's lambda. And what's the coefficient of this OX, of B from this OX? That's 2 upon 5 mu. So mu, we now have the value. We can replace it by 5 upon 3. So this 5 and this 5 gets cancelled out. And we have the value of lambda, which is 2 upon 3. And you will find lots and lots of questions following this pattern. And all of them are done the exact same way. Okay. ये आप लोग किस ज़बान में बात करें? What language is that? सर प्लीज़ बता दें, सर बता दें कि वेक्टर को खोलते हुए उसकी डायरेक्शन कौन से डिटरमिन करते हैं कि प्लस करना है या माइनस. Okay, so if the vector that you're taking is in the same direction as the arrow, okay, so you take it with a plus sign. But if you're going opposite the arrow, then you make the minus sign. Okay, that's a very simple question. If let's say, like for example over here, if I'm going from O to A, I'll take it as positive A. But if I'm going from A to O, then I'm gonna take that as minus A. Okay, I hope that was your question, and I hope that answers it. Mu is it's a Latin word. So you know how you have alpha, beta, gamma, delta, mu, phi. So these are all what do you call these are all Latin words. Okay. Thank you, Jazakallah. PDF of the questions, you'll find it in the description. उसको open करते हुए, okay, इसको open करते हुए. So for example, if you have AB, now you can open up AB by either doing AO plus OB, or you can open up AB by either doing OB minus OA. It depends on the vectors that are given to you, okay, and on the basis of that we decide what to do. Okay, if let's say you're dealing with position vectors, then this is the better approach, that AB split open can be written as OB minus OA. ऐसा हो नहीं सकता that arrows are not given. Okay, that's not possible. Yeah, we'll do some ratio problems as well. Don't worry about it. अभी तो stream शुरू हुई है, अभी से आप लोगों को tension हो रही है. Okay, this is pretty easy. In fact, so let's do this. Here, this has a parallel concept, so let's do this. Okay. So it says here, relative to an origin, the position vectors of A and B are so and so. Okay. Write down an expression for AB. Okay. Now AB can basically be formed by doing OB minus OA. Okay, so OB minus OA gives us AB. So AB is equal to what? OB. Now what's OB? That's 11I plus 42J. Okay. Now I say here's my suggestion. Okay, here's my suggestion. My suggestion is that you first write it like this. Okay, so you have 2I and minus 3J, right? So you write it like this. This makes the addition subtraction part easier. And OB, write it like this, 11 and 42. Okay. Now if you're doing OB minus OA, so that means 1142 minus 2 and minus 3. So what's 11 minus 2 equal to? That's 9. What's 42 minus minus 3 equal to? That's 45. Okay. So here we have AB, and then you can write it nicely. That is 9I plus 45J. Okay. And is that the answer? Yep, that's the answer. Okay. Okay. Then it says the point C lies on AB such that AC is equals to 1/3 of AB. Okay. So AC is equals to 1/3 of AB. That means 1/3 of 9 and 45. So what's 1/3 of 9? 1/3 of 9 is 3. Okay. And what's 1/3 of 45? That's 15. So that's AC. Okay. Now before I can find out the length of OC, I need to find out the vector OC. Okay. Now how can I split this open? How can I split open AC? AC you can split open by doing OC minus OA. Okay, OC minus OA. Remember this rule that the element that's near comes first, the element that's further away comes after. Okay. So that's what I'm going to do now. I'm going to split open AC and write it as OC minus OA, and OA means that I can replace it by 2 and minus 3. So 2 and minus 3, which is then equal to AC, which is 3 and 15. Now make OC the subject. So OC will now be equal to 3, 15 plus 2 and minus 3. All right. Now do not end up changing the signs of the components. Okay, that's an incorrect approach. We don't change the sign of the components. We only change the sign in between. So 3 plus 2 is 5. 15 minus 3 is 12. Now here is OC. If you want to find out the length, how do we find out the length? You can find out the length by simply taking the square root of 5 squared plus 12 squared. So 5 squared is 25. 25 plus 144 is 169. And the square root of 169 is 13 units. So there you go. The magnitude of OC, or you can say the length of OC, is 13 units. Okay. All right, now here is part 3. Now take a good look at part 3 and tell me how exactly are we going to solve it. Don't solve it, but at least tell me how exactly are we going to solve it. Sir, this is a little off-topic question, but when we have single matrix, how do we take its inverse? What do you mean single matrix? How do we take its? It's the same formula that we use: 1 upon AD minus BC, which is equal to, and then you multiply that by the adjoint matrix. Okay. Okay. Now, so here's how this works. I'm solving this. So the question says that the point D lies on OA. Okay, so that means if somewhere over here, if let's say this is vector OA, okay, so point D lies over here. Okay, so if point D lies over here, that means OD is actually going to be some times of, or you can say some constant times of OA. So OD you can say is going to be equal to K times of OA. Why is that? Because they're collinear. Alright. Since we don't know that where exactly point D is, so if OD lies on OA, so that means the vector OD is going to be some times of OA. Okay. So that means I can't find out the exact vector OD, but here's what I can find out. I can find out OD by taking vector OA and multiplying it by K. And what's what vector OA? It's 2 and minus 3. So here's 2 and here is minus 3. Okay. So that means 2K and minus 3K. Alright. So this is what vector OD is going to be equal to. Okay. Now, another thing that we know is that DC is parallel to OB. Okay. So DC is parallel to OB. So let's find out DC. How can I find out DC? DC can be found by simply doing OC minus OD. Okay. OC minus OD. Now we have OC. Okay. What's OC? OC is 3 and no, wait a minute. OC is 5 and 12. Okay. And from it, let's subtract OD, which means 2K and minus 3K. So this is vector DC. Let's write this down. DC is equals to 5 minus 2K and 12 plus 3K. Alright. Now according to the question, vector DC is parallel to OB. Okay. Vector DC is parallel to OB. What does that mean? That means what is vector OB? Let's write that down. Vector OB is 11 and 42. 11 and 42. Okay. Now, here's what we're going to do. 5 minus 2K. Okay. This is the x component of DC. Divide by the x component of OB. And that is going to be the same as the y component of DC, which means 12 plus 3K divided by the y component of OB, which is 42. Okay. And now what we're going to do is we're going to cross multiply and find out the value of K. Okay. So let's do that. Let's see if we can simplify. No, I don't think we can simplify this. Yeah, I don't think we can simplify this. So let's just cross multiply 5 into 42. So that's equal to 210 minus 42 into 2. So that's 84K, which is equal to 11 into 12. So that's 132 plus 33K. Okay, so let's get all the K's on one side and let's get all the constants on one side. So minus 84 minus 33. So that's equal to minus 117K, and 132 minus 210. So that's equal to minus 78. Yeah, 132 minus 210. Okay. So K turns out to be equal to what? K turns out to be 2 upon 3. Okay, now that's not the end of the question. We've only found out the value of K, and we need to find out the position vector of D. So remember, OD was equal to 2K and minus 3K. So 2 into 2 upon 3 and minus 3 into 2 upon 3. So let's solve this. See what we get. So we get 4 upon 3 and this gets cancelled out. So that's equal to minus 2. So 4 upon 3 and minus 2 is the answer, which you can write as 4 upon 3I minus 2J. So there you go. Now this was a tricky question, and you can expect questions like this to be in the exam. Sir, why are we not dividing but not equating? Okay, so the reason why we're dividing is because it says they're parallel. Okay, the reason why we're dividing is because it says they're parallel. Now, when two vectors are parallel, what does that mean? That means the ratio of their components will be the same. How did we get 11 upon 42 as the denominator? So remember, when two vectors are parallel, the x component of one vector divided by the x component of the other vector is going to be the same as the y component of the other vector divided by the y component of the other vector. Okay, so this helps you finding out the value of K, and then you replace the value of K in OD to find out the actual vector. Yes, in parallel, the ratio is always the same. Okay, so I'll give you guys a quick recap of this. Okay, so OD is parallel to OA. That means OD is going to be some multiple of OA. Okay, so we took that multiple to be K. All right. Then here's what we did. We found out DC by using the subtraction rule. So here's DC in terms of K. And OB we already had. Now, since these two vectors are parallel, that means if you take the x component of this vector, divide by the x component of this vector, this is what you get. That ratio is going to be the same as the y component of this vector divided by the y component of this vector. Okay. And then you cross multiply to find out the value of K. Once you have the value of K, you plug that back into this to find out the actual vector OD. Now, that's a good question, that how come it's of 2 marks? Well, this is what it is, so there's nothing we can do about it. All right. Apparently, you get 1 mark for doing all this, and you get 1 mark for writing the final answer. So these are some old questions, May, June 2012, paper 2, variant 1. You know how people in the old days used to be smart? So this was easy for them back in the day. Okay, did I miss anything, sir? Can we erase the working if space limited on the exam paper? Just make sure it's not some relevant working that you end up erasing. Then yeah, of course, there's nothing stopping you from doing that. No, the magnitude will not be the same. Okay, when two vectors are parallel, remember it's only the ratio of their coefficients that's the same. Okay, is it important that two parallel lines have to be of the same length? No. Okay, parallel lines have the same gradient, the lengths can vary. Yes, I can do recent past papers as well, don't worry about it. Okay, चलो अब एक काम करते हैं. Now that we've done 3 old questions, 3 ancient questions, let's do some recent questions. Sir, you have a tip for proving trig identities? भाई देखो, हर चीज़ की कोई tip नहीं होती, ठीक है? Sometimes you just need to keep working till you get the right answer. Okay, so stop trying to look for shortcuts and everything like tips and tricks. Okay, sometimes it's just old school, old fashioned way that you just keep solving till you get the right answer. That's it. Okay. All right, let's do another question. What do you guys say? Let's do, let me pick a difficult question. Okay, now here's a question. This is from October-November 2020, paper 1, variant 3. Okay, October-November 2020, paper 1, variant 3. Let's see what it says. So it says here the diagram shows triangle OAC. Okay, the point B is the midpoint of OC. The point B is the midpoint of OC, so that's very important. We'll come back to it. Okay. The point Y lies on AC such that OY intersects AB at the point X, where AX and XB are in the ratio 3:1. Okay, so that means this is 3 part and this is 1 part. All right. Then it says it is given that OA equals to A and OB equals to B. All right, OB equals to B and OA equals to A. Find OX in terms of A and B, giving your answer in its simplest form. Okay. Now, before I go on and find out OX, okay, this is what we know. We know that vector BC is also going to be equal to B. Okay. And yeah, that's pretty much it. Okay, that's pretty much all that we can find out by reading the question. Okay. So OX can be found by simply doing OA plus AX. Okay. Now, if this is what we have to do in order to find out OX, that means we can't do that. Okay, even though we have OA, which is A, but the question is that where do we get AX from? Now, for that, we go back to the question where it says AX and XB are in the ratio 3:1. Okay, yeah, you know, AX and XB are in the ratio 3:1. Okay. Now, this means that AX is actually equal to what? AX is actually equal to 3/4 of AB. Okay, now why is that true? Let me explain this on the side. So here we have A, and here we have X, and here we have B. Okay, so if AX is 3 parts and XB is 1 part, that means altogether this has been divided into 4 parts, and AX is actually equal to 3/4 of the total. That means it's equal to 3/4 of AB. Okay, now I can find out AX. AX is going to be 3/4 of AB. Now what's AB going to be equal to? Let's write that down. Let's write AB over here. AB is going to be equal to AO plus OP. So that means it's going to be equal to minus A plus B. So let's replace that over here, minus A plus B. So AX is equal to minus 3/4 of A plus 3/4 of B. Okay. Now we have everything we need. A plus minus 3/4 of A plus 3/4 of B. So A minus 3/4 of A will be 1/4 of A plus 3/4 of B. Now if you want, you can leave it like this, or if you're like me who has some OCD issues, so I would prefer to write it like this: 1/4 common, A plus 3B. No, it looks much nicer this way, but if you leave it like this, then it's perfectly all right. Okay. Okay, now then we have to find, I hope this is clear, AC in terms of A and B. Okay, so AC निकालना तो आसान है. AC, that means A from O and then from O to C. Alright, so AC means A from O and then from O to C. So that will give us AC. Now AO is minus A. Alright, AO is minus A, and OC is going to be 2B. So minus A plus 2B. And that gives us AC. So there you go. That's that. Achha, let me clean this up. Let me take a screenshot of this. Okay, now this is exactly what we dealt with earlier. Okay, exactly the first question, or maybe the second question, I don't remember which one it was. This is what we dealt with earlier. Now let's see what this says. Did I miss anything important? When do we need to find gradient of the curve? We differentiate when the question says so. When the question says find the gradient of the curve at so and so, or maybe when the question says find the equation of tangent or normal, that is when we need to find out the gradient of the curve. Okay. All right. Now, so here it says, given that OY is equals to h times of OX, find AY in terms of A and B. Okay. So how can I find out AY? Here's what I can do. For AY, what I can do is I can go from A to O, okay, and then from O to Y. Yeah, I can do that. So AO is minus A, and OY, as the question says, is h times of OX. Now what's OX? I believe we've already worked out OX. Yeah, we've already worked out OX. Okay, so there you go. AY is going to be equal to minus A plus h times of OX, which means 1 upon 4A plus 3 upon 4B, which means 1 upon 4A plus 3 upon 4B. Now, you're not supposed to simplify this over here, okay, but you will have to in the next part. Okay, now, sir, कोई वीडियो बता दें जिसमें okay, I have no idea what you've written there. Now here's part D. Part D again. Now notice here you found out AY in terms of h, and here again you'll find out AY in terms of some other unknown. Okay. So, and then you will have to use the two vectors to find out the value of the two unknowns. So AY, according to the question, is equal to m times of AC. That means now the same AY is equal to m times, and AC I believe is something we've worked out earlier. Yep, it's minus A plus 2B. Okay. Now here is one AY, which is going to be minus m times of A, minus m times of A, plus 2 times of MB. And we worked out another AY earlier, which is right here. Okay, in fact, so let me write it down again, and I'll write it down nicely, which means it's going to be minus A plus 1/4 of HA, okay, plus 3/4 of HB. Okay, now let me rearrange this and write it nicely. So if I take A common, so it's going to be In fact, एक काम करते हैं. First, let's write the positive value and then the negative value. Okay, so if I write the positive value first, so it's 1 upon 4th h a minus a. Yeah, that's better. Now, if I take a common, so I have 1/4 of h minus 1 with an a outside. Okay, and then in the next part, here's what I have. 3/4 of hb. Now, what are we going to do now? We're going to compare the coefficients. Okay, so let me drag this over here. Now, what is the coefficient of a from the blue AY? Okay, so let's call this the blue AY and let's call this the red AY. In blue AY, the coefficient of a is minus m. Okay, and in red AY, the coefficient of a is equals to 1/4 of h minus 1. So this is one equation. Okay, not good enough for us to find the value of m or h, but the good news is we can form another equation. What's the coefficient of b from the blue AY? That's 2m. And what's the coefficient of b from the red AY? That's 3/4 of h. Okay. Now what we need to do is we need to solve them simultaneously. Okay. Now before we solve them simultaneously, it's best that we write them nicely. Okay. So I think I'm going to use substitution. Yeah, it's best that I use substitution. Elimination would be a pain over here. So I'm going to go with substitution. Let me switch to black here. So let's cross multiply. So 8m is equals to 3h. Let's make m the subject. M is equals to 3 upon 8h. So this is the third equation, which goes back into the first equation. So that means minus 3 upon 8h is equals to 1/4 of h. 1/4 of h minus 1. Okay, so let's get all the h's on one side and all the co-constants on one side. So we take this 1 over here. We let the 1/4 of h be as it is and bring 3 upon 8h on the right hand side. Okay, so here's what we have. 1 upon 4 plus 3 upon 8. So that's equal to 5 upon 8. All right. So 1 is equals to 5 upon 8h. Make sure that you guys don't make a calculation error over here because that would be just throwing away marks. So h is equals to 8 upon 5. Cross multiply, you have h is equals to 8 upon 5. Now let's find out the value of m. Remember, m was equals to 3 upon 8 times h. So now it's going to be 3 upon 8 into 8 upon 5. So this 8 and this 8 gets cancelled out and m is equals to 3 upon 5. So here's the value of m and here's the value of h. Now here is the entire question. Take a good look at it. Let me shift this over here. Yeah. There you go. Okay, so you have everything in one frame. And yeah, that's it. So what are your thoughts on this question? Okay, I'm sorry, I will not be doing velocity vectors because I already have a stream on velocity vectors. Just look it up, you'll find it. Okay, look it up, you'll find it. I did a stream very recently and there are no questions left. There aren't any questions that I haven't solved already. Okay. Easy and long. Could you recommend a video to solve the issue for showing and proving the question in mensuration? Are you talking about math or are you talking about AdMaths? AdMaths में जो stationary value questions होते हैं. What are you talking about? Yes, synthetic division is allowed. Synthetic division is allowed. What's the rarest? Can we do AY minus AY for part C? Okay, I'm not sure what that means. Okay, let's move on. Difficult ones. All right, So let's do a difficult one. Now this is a super lengthy question and also a difficult one. Let's see what it says. So this is from, just so you guys know, this is from October November 2020 paper 2 variant 2. Okay? And it's quite a lengthy question. Okay? So it says here in the diagram OP is equals to 2B, all right, OS is equals to 3A, and SR is equals to B, SR is equals to B, and PQ is equals to A. Okay, perfect. The lines OR and QS intersect at X. Find OQ in terms of A and B. Okay, so how can I find out OQ in terms of A and B? Here's what I can do. OQ is equals to 2B plus A. That's it. Why? Because you're going to go from O to P and then from P to A. So O to P is 2B and then P to A is A. So 2B plus A is OQ. All right. Then it says find QS in terms of A and B. Okay, so how can I find out QS? So for QS, I can go from Q to R and R to S, but the problem is I don't know what QR is. So we'll have to think of something else. We can go from Q to P and then from P to O and then from O to S. Yeah, okay. So that's what I'm going to do. QP ke liye, I will go from QS ke liye, I will go from Q to P and then from P to O and then from O to S. So QP is going to be minus A, PO is going to be minus 2B, okay, and OS is going to be 3A. So let's see what do we get. So minus A plus 3A is going to be 2A, okay, and then the minus 2B. So QS is equals to 2A minus 2P. Okay, so there you go. That's the answer too. So far it's pretty easy. Okay, so far it's pretty easy. Now, then it says given that Qx is equals to mu times of Qs. Okay, so Qx is equals to mu times of Qs. Now, since we've already worked out Qs, so we're going to replace it by 2a minus 2p. Okay. Now, that's it. There's nothing else we have to do over here, but we might as well write it nicely. So this becomes 2 times of mu a minus 2 times of mu b. Okay, and that's it. Now, then the next part says, given that OX is equals to, now this question has difficult parts, okay, you have difficult parts over here, so hang in there. इतने जल्दी आप ये ना conclude कर लें कि ये आपके लिए आसान है, you might struggle in the later in the latter parts, okay. Then we have OX, which is equal to lambda times of OR, and now we need to find out OX in terms of A, B, and lambda, okay. So OX is equals to lambda times of OR. Now, have we worked out OR? No, we haven't, but we can work it out. OR will be 3a plus b. Okay. OR is equal to 3a plus b. And there you go. That's OX. Okay. Then it says find the value of lambda and mu. Okay. Now, notice that we have QX. Okay. We have QX, which is right here. And we also have OX, which is right here. Okay. Now what I need to do is I need to find out QX again, but in terms of lambda. Okay, I need to find out QX again, but in terms of lambda. Have I solved this earlier? Okay, well, too bad if I've solved this earlier. Koi baat nahi. Let's do it again. There are plenty of questions that I solved multiple times. Okay, so now we need to come up with another vector that will take us from Q to X, and that vector has to be in terms of lambda. Okay, so that's what I'm going to do. So I can form Qx by simply going from Q to O and then from O to X. Okay, so Qx, another Qx can be formed by basically going from Q to P, so that's minus A, and then from P to O, so that's going to be minus 2B as well. Okay, and then going from O to X, which we know is equal to lambda into 3a plus b. Okay, so this is Qx, but this Qx is in terms of lambda. Okay, this Qx is in terms of lambda. So minus a minus 2b plus 3 lambda a plus lambda b. So we rearrange this, and this is what we get. We get minus a plus 3 lambda a plus lambda b minus 2b. Okay, so let's take a common. So we have minus 1 plus 3 lambda times a. Okay, and here let's take b common. So we have lambda minus 2 times b. Okay, now this is the green qx. We'll compare it with the red qx, and one by one find out the coefficient. So the coefficient of a from this qx is 2 times of mu, and the coefficient of a from this qx is equal to minus 1 plus 3 lambda. Rough sheet nahi beta, jo bhi working karni hai, it's best that you do it in the space that's provided to you. Okay, it's not at all recommended that you borrow any extra sheet. ठीक है, in the worst case scenario में आप कर सकते हैं, ठीक है, but other than that, no, I will not recommend. Okay. Okay, so as I was saying, yeah. So here is one equation where 2 mu is equals to minus 1 plus 3 lambda. Okay. And then let's form another equation where we compare the coefficients of b. So that is going to be minus 2 mu. Okay. Minus 2 mu is the coefficient of b in the red qx, and that's going to be equal to lambda minus 2. All right. So there you go. Here are the two equations. Let's solve them simultaneously. Let me just check all the working that I've done so far and make sure that it's correct. So okay, yeah, seems all right so far. So solving them simultaneously, okay, I can simply add the two equations. Yeah, if I add the two equations, this gets eliminated. So here we have 0, which is equal to minus 3 plus 4 lambda. Okay, so 3 is equal, basically you have to solve them simultaneously, whatever method you use. So lambda is equals to 3 upon 4. Okay, and now you can use any one of the two equations to solve for the value of mu. So I'm going to go with the first equation. So 2 mu is equals to minus 1 minus 3 into 3 upon 4. Okay, so 2 mu is equals to, let's see, what do we have? We have plus, sorry, not minus. 3 into 3 divided by 4 minus 1, so that's 5 upon 4. And now if you solve for the value of mu, so that's going to be 5 upon 8. Okay, so there you go. We have the value of lambda and the value of mu. And that's it. That's your answer. So I thought we had to find OX. Okay, so we had to find OX and we did it over here. And so we already had found QX. So I found QX again in terms of lambda. And I compared this QX, which was in terms of lambda, with the QX that was in terms of mu. Okay. Simultaneously इसलिए किया because, okay, now I'll repeat what I've done. So first of all, we had already found QX in terms of mu. Alright, we found QX in terms of mu. This is what it was equal to. Now we found another QX, but in terms of lambda, for which here's what we did. We went from Q to P, then P to O, and then from O to X. Okay, so Q to P is minus A, P to O is minus 2B, and then OX, which we already found over here in terms of lambda, and that was lambda into 3A plus B. Okay, now we have another QX, which is in terms of lambda, and here we have another QX, which is in terms of mu. So what we do is, when you have found two vectors, but in terms of two different constants, then what you do is you compare the coefficients. You will find questions like these. You'll find lots and lots of questions like these, and like I said earlier, all of them are done the exact same way. Okay, so since they're both equal, that means the coefficient of A from this vector is going to be the same as coefficient of A from this vector. And here also, the coefficient of B from this vector is going to be the same as the coefficient of B from this vector. Why? Because they're both equal. Okay, so you solve them, and you solve them simultaneously. You make two equations like I did over here. मैंने देखो color code किया हुआ है. Okay, I've color coded it. I'll do that again. I'll do the color coding part again. So here is the coefficient of A, and here is the coefficient of A, and then just like that, here is the coefficient of B, and here's the coefficient of B. Okay, so you solve them simultaneously and you get your answer. So in part C, you have put qx, but the question says find ox. Oh, okay. ठीक है, सही. अच्छा, okay. जब भी someone was saying earlier that we could have used ox over here. Yeah, you're right actually. So here we had to find ox. So I think that part I've done over here. No, I haven't. Khair. Anyway, just a second. Yeah. So someone's pointed out, and that's absolutely correct, that in part C we actually had to find out ox. Okay. So ox हम निकाल सकते हैं using qx by basically going from O to Q and then from Q to X. And O to Q we've already found. So that's going to be 2b plus A and then plus QX, which is going to be mu into 2A minus 2B. Okay, yeah. Thank you for pointing that out. So yeah, who was that? Sunbeam. Okay. When the question says parallel, then you divide, but when you have found two vectors and they're both the same, but they're in terms of two different unknowns, then you equate them and solve them simultaneously. Okay. Acha, the reason why I'm not resolving velocities is because I did a stream on it recently only, so there's no point in doing a stream or again. Okay. Alright, now here's part F, which says find the value of qx over xs. Okay. Qx over xs. Now let's do this. Okay. Now notice the question said earlier that qx is equals to what? The question told us earlier that qx is equals to mu times of qs. Okay. This is something that the question told us earlier, that qx is equals to mu times of qs. Now we know what mu is equal to. Okay. So here's what I can do. Qx upon qs is equals to 5 upon 8. Now what does that mean? अच्छा, ये 5 upon 8 कहाँ से आया? In case you're wondering, this is what mu is equals to. So qx upon qs is equals to 5 upon 8. Okay. So I've taken qs over to the other side, divided it, and qx and qs are in the ratio 5:8. Okay. Now what does that mean? That means if qx is 5 parts, then the entire qs is how many parts? Then the entire qs is 8 parts. Then with the help of that, can I find out xs? Yes, I can. That's 3. Now you don't have to go through the pain of finding the vector. Okay, vector nahi nikalna aapne aap. You just need to find out the ratio. So qx and xs are now in the ratio what? Are now in the ratio 5:3. Okay. Now here's part F. Part F says find the value of OR upon OX. Now if you go back, notice here the question said that OX is equals to lambda times of OR. So OX is equals to lambda times of OR. That's what the question said, right? Let's go back, make sure of that. Yeah. Okay. So now that we know what lambda is equals to, we know that lambda is equals to 3 upon 4. So that means OX is to OR is equals to 3 upon 4. But don't get carried away and say that 3 upon 4 is the answer. No, it's not. Remember, you're supposed to find out OR upon OX. That means you will take the reciprocal of it. And if you take the reciprocal of it, what do you get? You get 4 upon 3. So 4 upon 3 is the answer. या ओके सो यहाँ पे ज़रा थोड़ी सी मैंने लंबी कर दी. ठीक है, लंबी इसलिए हो गई क्योंकि मैंने यहाँ पे ये नहीं देखा कि हमें OX चाहिए था. ओके, सो टेक्निकली वी हैड टू यूज़ OX फ्रॉम हियर एंड वी हैड टू यूज़ द OX फ्रॉम हियर एंड देन सॉल्व दिस. ओके, सो जस्ट मेक अ नोट ऑफ दैट. How do you know when two objects meet or not? Okay, so you equate their displacement at t. You equate their vectors for displacement at t, and if you are able to find a value of t and they're both the same, okay, for both the equations, that is when they meet. Again, I've done a stream on this recently. Please check it out. That stream will definitely help you guys in case a question comes tomorrow. So like I said, just make sure to check it out. Let me see कि मैंने कब की है stream. So yeah, okay. So I did a stream on 1st April 2023. Okay, it's an hour-long stream where I've solved plenty of questions. So check it out. It will definitely help you guys, inshallah. Okay, and I have another playlist where I have explained the concept. Okay, I have another playlist of vectors where I've explained the concept. So make sure to check that out as well. From there you can learn the concept of resolving velocity and everything. 1st April, yeah, 1 month ago. Okay, you guys want to do an insanely difficult question? I think I've done a stream on that as well. Stationary value करके देखो मेरी जो playlist है ना, where yes, velocity vectors are in the syllabus, so level and IGCSE. Yeah, just check the playlist where I have all the streams in one place. You'll definitely find a stream by the name of stationary value. Okay, you'll find it there. Okay. All right, let's do a difficult question. ये भी काफ़ी predictable question. The thing about vectors is you solve 4 or 5 questions and then every other question, I'm talking about just vectors, I'm not talking about bearing or velocity vectors or anything of that sort. I'm talking about just vectors. You do a few questions and then you'll realize that every other question is very similar. चलो ये question करते हैं, ठीक है? This is from May June 2017, paper 1, variant 1. तलहा मैंने अभी कुछ टाइम पहले वेलोसिटी वेक्टर्स की स्ट्रीम की है, ठीक है? तो आप जाके उस स्ट्रीम को देख लो, कवर हो जाएगा, सही है? There's no point in streaming something that I've already streamed, okay? Might as well stream something that I haven't streamed before. Okay, now, here's a question. Let's see what this says. So this question here says, the diagram shows a figure OABC, okay, where OA equals to A and OB equals to B. Okay, so let's have a look at the diagram also. OA equals to A, OB equals to B, and OC equals to C. The lines AC and OB intersect at M. The lines AC and OB intersect at M. Alright, where M is the midpoint of the line AC. Okay, where M is the midpoint of the line AC. You'll find this worksheet in the description. Okay. Now, then it says find in terms of A and C the vector OM. Okay, so how can I find out vector OM? So OM can be found by going from O to A and then from A to M. Okay, so that's how we can find OM. OA is going to be A plus AM, and AM, okay, now the question is how do we find AM? So AM, since M is the midpoint of the line AC, so that means AM is basically going to be half of AC. Now can I find out AC? Yes, I can. AC can be found by simply going from A to O, which is minus A, and then from O to C, which is C. Okay, so we have minus half A plus half C as AM. Okay, so you replace that over here, minus half A plus half C. So A minus half A equals to what? Is equals to half of A plus half of C, and that is what OM is equal to, half A plus half C. Okay, so there you go. That's your answer. Okay, now let's do the next part. The next part says, given that OM and MB are in the ratio 2:3, find B in terms of A and C. Okay. OM and MB are in the ratio 2:3. Okay. And also we know from before that OB is equals to P. Okay. अच्छा हमें क्या चाहिए? हमें चाहिए B in terms of A and C. Okay. Interesting. Okay. Now चलिए बताएं कैसे सॉल्व करेंगे इसको. How exactly will we get B in terms of A and C? Question for you guys. Ratio, okay. What else? What else can we do to find out B in terms of A and C? Just make sure you read the entire question. Okay. The only thing important in the question is that the lines intersect. M is the midpoint. Okay. Yes, find OM. Okay. Now this question is nice in the sense that we've already found out OM. Okay. So OM is something like I said we've already found. It's half A plus half C. Okay. And according to the question, OM upon MB, they're in the ratio 2:3. Okay. Now what is MB going to be equal to? Okay. MB, if you think about it, MB is going to be equal to 3/5 of B. Okay. MB, since MB is 3 parts and the entire OB is 5 parts, so MB, basically there would have been a step earlier. MB is going to be equal to 3/5 of OB, which means that MB is going to be equal to 3/5 of B. Okay. Now, ऐसे भी कर सकते हैं हम, या हम ये भी कर सकते हैं कि OM is equals to 2/5 of B. Okay, we can do that as well. MB is equals to 3/5 of B, or we can also say that OM is equals to 2/5 of B. That's actually much easier. Since we already have OM, okay, let's use this. OM is equals to 3/5 of B, or 2/5 of B. So one OM is this, and the other OM is 2/5 of B. So that's what we're going to do. Let's write this nicely. Let's write OM as half of A plus C. Okay, so this is OM right here. And the same OM is also equal to, sorry, A plus C. And the same OM is also equal to 2/5 of B. अब हमने क्या करना है? अब हमने दोनों को इक्वेट करना है. ठीक है. So half of A plus C is equal to what? Is equal to 2/5 of B. Okay, so let's cross multiply. There's nothing we can cancel. But क्योंकि हमें B को subject बनाना है ना, so just multiply, just cross multiply. Take 5 over to the other side and take 2 over to the other side. So this is what we get. 5 upon 4 into A plus C. 5/4 of A plus C. So this is what B is equal to. Okay, so there you go. That's your answer. Okay, 5 minute की ज़रा break लें. What do you guys say? Let's take a 5-minute break. Okay, मैं एक recap दे देता हूँ. ठीक है. So OM and MB are in the ratio 2:3. OM we already found out over here. OM we found out to be half A plus half C. Okay, and we can find out OM using this ratio. Okay, so OM is going to be equal to 2/5 of B. Why 2/5 of B? Because OM is 2 parts and MB is 3 parts. So altogether this has been split into 5 parts, which means that OM is 2/5 of the total. So here's OM in terms of B, and here is OM in terms of A and C. You equate the two OMs and just make B the subject and you'll have the answer. Sir, could you solve question 7 of, is that a vector question? Okay. Let's take a break. Let's take a 5-minute break and then we'll resume. Okay, iska part B. Yeah, काम करते हैं. So let's complete this question and then we'll take a break. Okay, let's not leave this question in the middle. Let's complete this and then we'll take a break. Okay. Now here's part B of this question. Part B says vector I and j are unit vectors parallel to the x and y axis. The vector p has magnitude 39 units and has the same direction as minus 10i plus 24j. Find p in terms of I and j. Okay, so now you'll come across questions like these a lot. The way to solve a question like this is that you take the magnitude, okay, magnitude and multiply it by the unit vector of the direction vector. Whenever the question gives you the magnitude and tells you in what direction you have to find a certain vector, you multiply the magnitude by the unit vector of the direction vector. Okay, this is the standard way of solving this. So what's the magnitude? The magnitude is 39. 39 gets multiplied by minus 10i plus 24j divided by its magnitude. Why? Because that is how you'll find the unit vector of the direction vector. So 10 square plus 24 square inside the square root, so that's equal to 676, जो कि बन जाएगा 26. So p is equals to 39 into minus 10i plus 24j divided by 26, such as 676, okay, not 672. Okay, so you can simplify this, and if you simplify this, here's what you get. 39 divided by 26, 13 3s are, 13 2s are. Okay, so here's what you're looking at. P is equals to 3 upon 2 into 10i minus 10i actually plus 24j. Okay, so if you multiply this, 3 divided by 2 into minus 10, so you get minus 15i. Okay, plus 24 into 3 divided by 2, so that gives you 36j. So you can remember this formula. If the question is asking you to find a vector of which you're given the magnitude and the direction, so you take the magnitude, multiply it by the unit vector of the direction vector. Okay, that's how a question like this is done. Okay, then it says find the vector q such that 2p plus q is parallel to the positive y-axis and has a magnitude of 12. Okay, अब ये ज़रा थोड़ा complicated सवाल है. ठीक है, let's see what we can do over here. It says find the vector q such that 2p plus q is parallel to the positive y-axis and has a magnitude of 12. Okay, now, so first of all, let's find out 2p plus q. Okay, so 2p plus q, here's 2 into p, which means 2 into minus 15i plus 36j plus q. Okay, now if you have a vector which is parallel to the positive y-axis, okay, if you have a vector which is parallel to the positive y-axis, what can you tell me about that vector? Any vector which is parallel to the positive y-axis, what can you tell me about it? So let's say here's a vector which is parallel to the positive y-axis. Okay, let's say ये AB है. Okay. So what's the one thing you can say for sure about AB? What is the one thing that you can say for sure about vector AB if you know for sure it's parallel to the y-axis? Yes, no I component. That is correct. That means it will have no I component and it will definitely have some j component. Okay. So if this is vector q, which apparently is parallel to the y-axis according to the question, positive y-axis, so that means it will have no I component. Okay, but there will definitely be a j component. Okay, so that means what do I know about q? I know that q is basically equal to what? I know, अच्छा wait, it's not actually q that is parallel to the positive y axis. ठीक है, ये तो चलो मैंने एक एग्जांपल दी थी. ठीक है, इसको हम एक काम कहते हैं, इसको हम a कह देते हैं. ठीक है, a भी नहीं बल्कि इसको हम r कह देते हैं. ठीक है, so if you have a vector r which you know is parallel to the positive y axis, okay, so remember this, it's not gradient equals to 0. In fact, the gradient is going to be infinity because it's a vertical line. Okay, so if you have a vector which is parallel to the positive y axis, so that means the x component will be equal to 0, or in other words, there will be no I. Okay, I will be equal to 0. Okay, now according to the question, a vector q क्या है हमें नहीं पता. Okay, so we don't know what vector q is. So let's say vector q is ab. We don't know what vector q is. It's not vector q that is parallel to the y-axis. Vector q is just ab. So this is what we end up with: minus 30i plus 72j, and like I said, since we don't know what vector q is, so vector q is equals to ai plus bj. So plus ai plus b into j. Okay, this is what 2p plus q equals to. Okay, now this is the vector that is parallel to the y-axis. This is the vector, this entire vector is the vector that is parallel to the positive y-axis. Now if this vector is parallel to the positive y-axis, that means the I of this vector has to be equal to what? Has to be equal to 0. Okay, so that's what I'm going to do. Here I'm going to get all the i's on one side, minus 30i plus ai plus 72j plus bj. Okay, now let's take I common. So minus 30 plus a into I plus 72 plus b into j. Now because this vector is parallel to the y-axis, that means इसका I component क्या होगा? इसका I component 0 होगा. So that means I can use that information to find out the value of a. So I will say that minus 30 plus a equals to 0, which means a equals to 30. इससे मेरे पास a की value आ गई. So that means here's what I know about q so far. I know that the components of q are 30 and b. Now the question is that how can I find out the other component? How can I find out the other component? How can I find out b? What information can I use in order to find out b? A will be 30, yeah, that's correct. But the question is, what information can I use to find out the value of b? Whoops, sorry about that. Substitute, okay, I've already done that. But what else? There's some other piece of information that I need to find out the value of b. Yes, I need to find out the gradient. Okay, I need to, no wait, not the gradient, I need to find out the magnitude. Okay, I'm going to use the magnitude to find out the value of b. Okay, now what's the magnitude? Here's what the magnitude is. Ab dekho, here's what we know about 2p plus q so far. About 2p plus q, we know that it's equal to 0i. Okay, we know that it's equal to 0i plus 72 plus bj. Now, according to the question, the magnitude of this entire vector is 12 units. So that means 0 square plus square root plus 72 plus b, the whole thing square inside the square root equals to what? Equals to 12. Okay. Up here, this is what we're going to do. 72 plus b, the whole thing square, equals to what? Equals to 144. Why? Because we've taken the square on both sides. Okay. Now, if you take the square on both sides, let's see what happens. We have 72 plus b, which is equal to what? Which is equal to 12. Okay. Now, that is one possible value of b, and the other possible value of b is that 72 plus b equals to minus 12. Let me drag this over here, because if you take the square root on both sides, this is what happens. 72 plus b is equals to plus minus 12. Now let's see. 72 plus b is equals to what? Is equals to 12, or 72 plus b is equals to minus 12. Now we get two values of b. Let's find out the two values one by one. एक जो वैल्यू b हमारे पास आएगी by solving this equation is b is equals to minus 60, and the other value b that we're going to get by solving this equation, let's see what that is. That's going to be minus 12 minus 72, so that's going to be minus 84. Now the question is, what value of b are we going to go with? Acha, एक second, wait a minute. Actually, there will be no plus minus. Sorry, my bad. Because the square root and the square will cancel out each other. Yeah, the square root and the square will cancel out each other. Let me do this part again. So since we know that the magnitude is 12, this is what will happen. 0 square plus 72 plus b, the whole thing square, is equals to what? Is equals to 12 square. Yeah, this is better. Inside the square root, or ओके नहीं, b की एक ही वैल्यू आएगी, मैं बताता हूँ क्यों. क्योंकि देखो एंड में ना ये हो जाएगा, एंड में हो जाएगा 72 प्लस बी द होल थिंग स्क्वायर which is equal to 12, and then the square root and the square will cancel out each other. Okay, so 72 plus b equals 12, and b will then be equal to minus 60. So this is the value of b that you're going to end up with. Okay, not minus 84, just minus 60. Okay, because there will be no plus minus, the square root and the square will just cancel each other. Okay, now I'll explain this again. Thoda complicated question hai. Once we found out the value of a to be 30, okay, that means our vector now looks something like this. Now this is what the vector now looks like, and now we need to find out the value of b, for which we are going to use the magnitude. So if you find out the magnitude of this vector, that means taking the square of the x component plus taking the square of the y component. What is that equal to? That's equal to 12. Okay, so 0 square, well, that just disappears. Okay, 72 plus b inside the square root, and then if you square it, the square root and the square cancel out each other, and that's equal to 12, and this is the equation that you use in order to find out the value of b. Okay, acha sir, we have to add constant when points are collinear or parallel. I'm not sure exactly what that means. We have to add constant when points are collinear or parallel. No, ऐसे कोई standard rule नहीं है. When points, how can points be parallel? Points can be collinear, lines can be parallel. Okay. All right. Then it says, hence show that. Okay, now that we know what vector q is, we know that vector q is 30 and minus 60. Now we need to find out its magnitude. So let's do that. 30 square plus minus 60 square. So 30 square is what? 30 square is 900. 900 plus 3600 inside the square root. So that's going to be equal to 4500. If you take the square root of 4500, what do you get? You should end up with something like what the question says. So 30 under root 5, yep, that's correct. So the magnitude of q is equals to 30 under root 5. That means k is equals to what? K equals to 30. Okay, there you go. Okay, so should we take a break here or should we end it over here? बेटा मेरे पास नहीं है IGCSE का पेपर सोल्यूशन. Please stop spamming. Can the moderator please take care of this? Okay. So, what do you guys suggest? Do we take a break or do we end it over here? वैसे काफ़ी है, I think. No, we don't equate in parallel vectors. We form ratio in parallel vectors. We equate the ratio. Okay. If let's say that you found two vectors and they're both the same, but you found them in terms of two different unknowns. Okay. Then you equate them. अगर दो वेक्टर्स हैं दोनों लेट्स से ए बी हैं एक इन टर्म्स ऑफ लैम्डा एक इन टर्म्स ऑफ म्यू है देन यू इक्वेट देम बट लेट्स से यू हैव वेक्टर ए बी एंड यू हैव वेक्टर पी क्यू if a b and p q are parallel then you find the ratio of their x components the ratio of their y components and then you equate that. Okay. Okay, so I think let's just solve one more question and then call it a day. Last part kya last part beta? Can you narrow it down exactly what you're saying? These are all past paper questions. You'll find it in the description. Okay. Do we round off our answers to 3, 4 significant figures? Yes, we do. You round off all non-exact answers. Okay. Any non-exact answer are rounded off, correct, to 3 significant figures. No, I meant for this stream. You're right, abhi to kinematics ki bhi stream hai. For this stream, I was thinking maybe we call it a day. Kinematics is in the syllabus or not? Please tell me. I hope आपका कल एग्ज़ाम नहीं है. चलिए ये सॉल्व करें आप लोग. This has a bit of not exactly velocity vector, but this has a bit of angles. So let's solve this question. But I'm not solving 2025 papers at the moment. Okay, where that is for students who are appearing in 2025 and later on. So please stop making these silly requests. You don't have to show all the working. Okay, just enough working to convince the examiner, या checker basically, that you haven't cheated. बस इतनी working आप दिखा दें, that's good enough. Let's solve this question and then let's end it. Okay. That's not in the syllabus. Okay. Sets and Venn diagram is not in the AdMath syllabus, and what you're saying is your still air and still water, these type of questions are also not in the syllabus. Okay, so anyone who has the answer to the first part? Okay, this stream is about to end. Okay, and then we have another stream of kinematics. This is from May June 2017, paper 12. Okay, so here's question number 17, part A. I'm solving it now. So the first part says the vector v has magnitude 305 units and has the same direction I minus 2j. Find v, giving an answer in the form of ai plus bj. So again, very similar question, 305 multiplied by the unit vector of the direction vector. So that means square root of 1 square plus minus 2 square. Okay, so 305 into I minus 2j over square root of 5. So what happens as a result is that this root 5 and this root 5 gets cancelled, and now we have 3i minus 6j as the final answer. Okay, there you go, 3i minus 6j as the final answer. Okay, then it says, okay, now read the next part and tell me what do you understand. The next part says, again, this is a velocity vector question. So, like I said earlier, I have a detailed stream on this. Okay, so you guys can check it out from there. Abhi main bas is question ko solve kar raha hu. It says the velocity vector w makes an angle of 30 degrees with the positive x-axis such that the magnitude is 2. Find w in the form of so and so. So that means the velocity vector w is in this direction. Okay, and it makes an angle of 30 degrees with the positive x-axis. So that means here is 30 degrees, and the magnitude of this green line is 2. Okay, now remember, if you want to find out, if you want to break this vector into its horizontal and vertical components, then here's what you will have to do. You will have to break it down into x and y components. Okay, so what you see in red is the x component, and then what you see in blue is the y component. Okay, now if you think about it, the red component is the adjacent side, and if you think about it, the blue component is the opposite side. Okay, now let's do the working for a. For a, we will use cos. So cos 30 is equals to adjacent upon hypotenuse. So a is equals to 2 cos 30. So let's see what that is. 2 cos 30. Okay, make sure your calculator is in degree mode for this one. So that's equal to under root 3. Okay, so that's what a is. Now for b, since b is the y component, so we'll use sine. So sine 30 is equals to opposite, which is b, upon hypotenuse, which is 2. And then if you cross multiply, b turns out to be equal to 1. Okay, and now you can write down the final vector. Because it's in the first quadrant, x and y, both of them will be positive. So under root 3i plus 1j, or simply j, is basically your vector w in terms of I and j. Okay, now again, if this is something that you haven't done before, then it's not too late. You can watch this stream on constant velocity vectors and revise this concept. Okay, it might come in the exam, and yes, it's part of the syllabus. Don't confuse this with relative velocity, which is no more part of the syllabus. Okay, so I'm gonna stop here. I will see you guys, well, shortly in 10-15 minutes, where we're learning kinematics. Okay, so that's it, boys and girls. Take care. Good luck for the exam. See you guys in 10-15 minutes.